Today we are going to talk about section 5.5, and it is going to be over logs with different bases. So there are going to be several new formulas that you need to know. First of all, I'd like to remind you that in order to graph a log of a different base, your formula for the change of base formula is natural log of whatever is with the log divided by the natural log of the base. Now keep in mind, if you're looking at this denominator here is just a constant. And the good news is you already know how to take the derivative of natural log of x. The other thing I'd like to remind you of is some of your properties. If you have a raised to the log base a of x, you get x. And if you have a log base a of a to the x, you get x. Just like when we did natural log, and it was e to the natural log of u, you get u. Or natural log of e is going to be 1. So these work the exact same way because this base is e and it's the, so you'll get whatever the exponent is. Okay, so this works just exactly the same way. So the formulas that you're going to have for this section, there's quite a few. The derivative of a to the u, a is a number. So the derivative of a to the u is u prime natural log of a times a to the u. This comes from the same formula that the derivative of e to the u came from. We had u prime, and if we put the natural log of e in there, it's the same thing as 1. So it is really the same formula. You just need to remember to multiply by the natural log of a. So if we're looking at an example, if our function is y equals 4 to the 3x, the derivative will be 3 natural log of 4 times 4 to the 3x. Keep in mind you'll still use the product rule, the quotient rule, and your other rules just the same. But if the function is a raised to the u, you want to follow this formula. Your other formula from this section is the derivative of log base a of x. Now, I started this video with reminding you that this is the same thing as natural log of x divided by natural log of a if we do the change of base formula. So my recommendation for this problem is to go ahead and rewrite it with the change of base. Now, because natural log of a is just a constant, and the derivative of natural log of x is 1 over x, you will have 1 over natural log of a as your coefficient, 1 over x being the derivative of natural log of x. So that's how I recommend doing the problem. If you want to just follow the formula, the derivative of log base a of x is 1 over natural log of a times x. If it is a u, derivative of log base a of u, then of course you will have a u prime. So u prime over the natural log of a times the u. So let's look at an example problem. If y Okay, sorry about that. My screen froze up. So let's look at an example. So let's do if y equals log base 3 of 2x minus 1. The derivative is going to be 2 over 2x minus 1, but then we have to divide it by the natural log of the base, which is natural log of 3. So you're still going to follow the formula u prime over u, but then you need to remember divide by the natural log of the base. Okay, so we also need to talk about our integral formulas. Okay, so the integral of a to the u du is a to the u divided by the natural log of a plus c. So you want to write out what your u is and work it the same way you would if it were substitution method. So for example, if I have 4 raised to the 3x minus 2 dx is my integral, the exponent will be my u. The derivative of that is 3 dx. So I divide by the 3. So I will have 1/3 integral of 4 to the u. In this case, my base is 4. And I'm just going to follow the formula. So I rewrite the problem. I have my coefficient of 1/3, and then I divide by the natural log of the base plus c. And that is section 5.5. The problems I would like for you to do are on page 366. I'd like for you to do number 38 and number 62. 38 and 62. Thank you.